Hello there. Today we'll be doing the problem called clock angle. This is a very interesting problem. Given a clock time, an hour and a minute, we are going to solve this problem and find out the angle between hours and minutes. The first observation I had was, does the hour hand move in between 12 through 1 slot? If so, how does it move? So we can answer this question by checking hours 12 and minutes 22. Then we map the hours to the degrees on the clock. So 12 is 0 degrees, and therefore 1, 2, 3, 4, 5, all the way up to 12. We get 12 items, and we have 360 degrees in the circle. So we get a total of 30 degrees per an hour. Then we use 0 minutes as 0 degrees, and then we have 60 minutes in an hour and in a circle. And so we divide that by 360, and we get 6 degrees per minute. So we have a total of 132 degrees at 22. If we subtract the two, we should have 132 degrees, but our output was 121, so that our hand does move. So by 11 degrees. So 11 degrees is 22 divided by 60 times 30 degrees, so 11. This means that we are going to take the minutes and divide it by the number within number of minutes in the hour, and multiply that by the 30 degrees, which we get in an hour. And so that basically means we multiply it by 0.5. And so once we have done all these observations, we can just do calculations at this point. The thing is, with this code, hours, we have to modulate the hours by 12 because it does not meet this constraint here, 0 to 23. As you can see later, this goes above 24. So I mean, it's under. It's over. Yes, it's under 23. So we do have to modulate the hours. Anything else? Yeah, we don't have 23 hours in a clock. Right, so let's see what's going on here. This should work, right? But it does not. And this code can be simplified. As you can see, it messes up here, even though it's greater than or equal to 180 degrees, as suggested. So how do we get that? Which one do we take? We take the least of the two, because, well, this doesn't work, as you can see. So let's redo this. All right. So hours is going to be equal to hour modulus 12. We're going to mod that by 12 because we want to get this within our boundaries. So let's get our hour degrees, and that's going to be hour times 30 plus the minutes times 0.5. Then we get the minute degrees, which is equal to minutes times 6, as we suggested earlier. The angle is actually going to be equal to the minimum of between the hour degree minus the minute degree, and 360 minus the absolute value of the h degree minus the minute degree. And that is, then we return the int of that angle, and we are good to go. I wonder what happens if we do math.floor. Also works, perfect. As you can see here, we have solved the problem clock angle. It's all about observations. What we learned here today is making observations, and eventually we'll get enough information to make a calculation to get our the answer to our problem. So it's just breaking the problem down into separate chunks and understanding what we're trying to do here, and what sort of output that we should expect, and create that algorithm. Well, I hope you learned something today. If you enjoyed the video, like and subscribe. If you want more videos, check the link in the description below. Thank you very much, and I'll see you in the next one.